Welcome back, class. Today we're doing chapter 12, starting off coming back from our spring break. Today we're talking about inverse variation. Before we talk about inverse variation, I want to do a little reminder as to what is direct variation. So let's come down here, look at this graph. Direct variation looks something like this. Okay, remember, if it's hot outside, you sell more snow cone sales. That's something that's a direct variation. As one goes up, the other goes up. As one goes down, the other goes down. Inverse variation is the opposite. As one goes up, the other goes down. So an inverse variation graph will look something like this here. Okay, and remember, when our direct variation, our constant of variation here, k, was equal to y over x, a division. And then you had the equation y is equal to kx. Okay, but now in direct variation, our equation is going to be y is equal to k over x. Y is equal to k over x, and our direct variation, k, is equal to x times y. Okay, so that's the two fundamental differences here, and you can remember it just by inverse opposites. So as one goes up, the other goes down. Okay, and we're going to look at some examples of this right now. All right, so your equation, y is equal to k over x, and k is equal to x times y. So let's scroll down here, and let's look at this. The cost of $20 worth of gas split among several people. So if it's just me and my best friend in the car splitting the gas, it's going to cost us each $10. Okay, but if we have add a couple more friends, it's me and 3 of my friends, there's 4 of us total now, it will only cost each of us $5. That's an inverse variation. Whereas the number of people go up, your cost goes down. Therefore, this is an inverse variation model. Okay, and in the next one, though, you buy several markers for 70 cents. As you buy markers, right, the more markers you buy, what happens to your cost? Well, your cost is also going to go up. The more you buy, the more it costs. So this is a direct variation, what we've already studied. Okay, but what we're going to be working with today is all about this inverse variation right here, these types of models. And what's going to be important is this piece of information here. K is equal to x times y, and y is equal to k over x. Let's take a look at another example. Writing an equation given a point. Okay, so suppose that y varies directly with x, and y is equal to 7 when x is equal to 5. Write an equation for the inverse variation. So it's first thing you need to do is step 1 is you need to figure out what k is. Find k. And we know that k is equal to x times y. So that's just going to be, well, x is 5 times 7, which is 35. Now plug that into your equation, right? So then you have y is equal to k over x. Well, I know that k here is 35, right? So I'll take this, plug this in here to come up with your equation y is equal to 35 over x. And that is your direct variation equation. Okay? So very simple to find the equation. Find k, then write it into your, plug it into the equation y equals k over x. Okay. In this next problem, we're going to be finding the missing coordinates. So the points 3, 8, and 2y are 2 points on the graph of an inverse variation. We need to find that missing value. So to start here, treat each of these points separately. The first point, I have 3, 8, right? I have an x value and I have a y value. If it is an inverse variation, I know that k is equal to x times y. X here is 3 times your y value of 8, which is going to leave you with 28. So the k value for my first point, 3, 8, is going to be 28. Now let's see if we can find the k value for my second point, which is at 2y. Okay, so k is equal to x is 2, and y is just y. So I have 2 times y. Now if these are two different points on the same inverse variation graph, then they have to have the same k value. So if I want to figure out what this y value is, I could set these two k values equal to one another. So I can come over here and say 24 is equal to 2y, because I know that k must be equal to k, therefore 24 must be equal to 2y. Then I can finish solving this by dividing both sides by 2. So now I have y is equal to 12. So the missing value, that missing point here, the coordinate, is 2, 12. Okay. All right, moving on. The weight needed to balance a lever varies inversely with the distance from the fulcrum to the weight. Let me move myself here. I'll move myself down here so that you can see my, there we go, so we can see the whole thing. All right, where should Julio, who weighs 150 pounds, sit to balance on the lever? So, you know, if you have like a teeter-totter here and someone's heavier than the other person, you can balance that out by your positioning to the fulcrum, which is the center here, indicated by this triangle. This here is the fulcrum, okay? And so I want to know, when will they be balanced? At what distance must Julio over here sit? What is this x value in order to balance the lever? Okay, so to do this, we have 2 points here, and we need to use what we know about inverse variation. So we have here, write them as 2 points if that helps you. Okay, so we have Julio on this side, and I don't know who the other person is. We'll call this person, I don't know, M for Mary. Okay, so Mary is 6 feet away, right? And her weight is 120 pounds. Julio over here, J, is, we don't know how far away, but is 150 pounds. So in order for them to be balanced, they need to have the same K value. So set these, find the K values here. So for Mary, Mary's K value is going to be equal to x times y. So let this be your x column and your y column. So x times y, which is going to be 6 times 120, okay? And 6 times 12 is 72, right? Let's double check here. Miss Ayers is, yep, I'm right. Very good. Okay, 72, so this is 720. Set that equal to Julio over here, and his K value is also x times y. And we don't know what his x value, we don't know how far away he's sitting, but I do know that he's 150 pounds. Okay, so this is 150x. And I know that if I want them to be balanced now, I need to set these two equal to each other. So 720 is equal to 150x. Then I can divide both sides by 150. Okay, and let's see what that comes up to. Okay, 150 divided, 720 divided by 150, and 4.8. So he needs to be 4.8 feet away from the fulcrum, from the center. Now, you can keep this as a decimal, but this is not 4 feet and 8 inches, by the way. Remember, 0.8 here, there's 12 inches in a foot. So 0.8 times 12, this is actually 4 feet and 9.6 inches if you were going to convert it. But you could just leave it as a decimal like this, 4.8 feet. Okay, and we have the very last examples here. All right, so determine if these tables here are direct variation. So to do this, remember that direct variation, you have y over x, and the one that we learned today, inverse variation, is x times y. So let's look at the first example here. We'll call this example A and example B. In example A, let's first see if it's direct variation. You take your y divided by x, so 5 over 2. It's already simplified, can't do much else. How about the next row is 10 over 4. I can simplify that to be 5 over 2. So far I'm looking pretty good. These are the same. And then the last one, 25 over 10, divide by 5 on the top and the bottom, you also have 5 over 2. So since I have 5 over 2, using this ratio here of direct variation, this first here represents direct variation because they all have this ratio of y over x that is the same, okay? And in the very last problem now, let's look at this one. I now have, if I tried for direct variation, I'll have 20 over 5, which simplifies to be 4. But then I have 10 over 10, and 10 over 10 simplifies to be 1. So direct variation is not going to work here, okay? So direct variation didn't work. So now let's try inverse variation. Inverse variation says you take x times y. So 5 times 20 is 100. Okay? 10 times 10 is 100. 15 times, I messed it up. I'm sorry, this is supposed to be 25. There we go. 25 times 4 is 100. So if they all come up to the same value when you multiply here, that means that these values, when you graph them, are going to represent an inverse variation situation. Okay, so that's tonight's assignment, tonight's homework. I know this was a little rushed. If you have any questions, send me an email, call, or text. Okay, thanks. Bye.